Hey guys, welcome to 4.1, using graphs to relate two quantities. On our essential question today, how do you represent mathematical relationships using graphs? Okay, as you can tell, this is a fairly short lesson. There's only really 4 slides here. So we're going to start out with kind of a little bit warm-up problem to get us thinking about how graphs work. Okay, and that's really what we're going to be doing today, is just looking at graphs and saying, what does that even mean? So for this one, the graphs below relate the height of the water to the volume of the water. Remember, volume is how much liquid is in a container, right? And so we need to determine which graph goes with which container, and then justify our reasoning. Okay, so let's just look at the pictures first off. So this one doesn't have very much height, right? This one has a lot of height, and then this one, it holds, as it gets taller. It holds a fairly constant amount, and then all of a sudden it holds like increasingly more water, right, as it gets higher. Okay, so like here it's gonna be holding less volume than, like, it's gonna be adding quicker up here than it would down here, right? Okay, so let's look at these 3 graphs. This is the height, right, and here this axis would represent the volume, or how much water is in there. Let's start off with this one. As the volume gets higher, the height does not get very high. And so which one would that represent? Well, it would probably represent, we'll use red here. It's probably going to represent this one. Okay, right? The height doesn't get very high, and the volume stays constant. Okay, no matter where you're at, it's adding at the same rate. Okay, now likewise, this one has a taller height, and it's also constant, right? There's no changes in its shape. It just goes straight up, right? And so here we see our line is constant. It goes straight. And so that one would relate to the second one. Now here, let's talk about this. It doesn't go at a constant, just like the shape is not constant, right? Another thing is that, as we get taller, all of a sudden the volume, it goes from being a constant increase to all of a sudden way more volume gets added with less height, right? So we don't have to go as high in order to get the volume we need. And so that would represent the weird shaped one. All right, so below we see a graph. It shows the amount of gasoline in Jamie's car after she fills up her tank. First, we need to determine what are the variables, and then how are they related to various points on the graph. Okay, so first off, our variables in this whole scenario. Well, first we have gas, right? That's one variable. How much gas we have, and that's constantly changing, right? And the gas is measured in gallons. Okay, that's one variable. Our other variable is time. How much time has passed since she filled up? So here would be her filling up, would be at time 0. Her tank is full at time 0, and then it decreases as we go. Okay, now if you notice, there are some time and days. We're getting our labels here. Okay, now it says describe how they're related to various points on the graph. Well, if we see here, she fills up and then she dries for a little bit, right? She dries for a little bit, so her tank goes down a little bit, and then her tank really goes down, right? Okay, so she must really used her car a lot that day. Maybe for this day she didn't use it a ton, but just a little bit, right? Then all of a sudden it stalls out and it just goes flat. What does that mean? Well, it means that she probably didn't drive her car this day, right? So for this period of time, she didn't use any gas. It just stayed constant. Okay? And then all of a sudden she starts to drive a little bit, but notice it's not very steep. It's not as steep as this line. And so that tells me that she probably didn't drive it a ton. She just used a little bit of gas. And then it stalls out again, right? So she must not have driven for this period of time. And then again, she uses a little bit more, maybe just to drive across town and go get a pizza or something. and then she uses a little bit more, but the rate changed, so she probably just drove to the, I don't know, drove to her friend's house right around the block or something, and then she uses even more. So as she uses more, the amount of gas that she has goes down, right? And this would be empty. If she got back to the x-axis, she'd be on empty, and she'd be pushing her car to the gas station. But she's headed that direction. And then if she would fill up again, then probably go like pretty much straight up, and she would start over fresh. Okay, so there's that graph. Now this one, the table shows the total number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Obviously, the first day they're not going to get a ton of people, and then word will get out like, hey, this car wash is open. That's pretty good. So then more people are going to show up. And so we need to figure out which graph out of these 4 would represent the data in the table. So we start off day 1, 61 people. So we start off pretty low. Then day 2, we pretty much double. Day 3, we add another 50 some people, and then day 4 it just explodes, right? And we add even more people. Okay, so which graph here would represent that? Okay, so as we look at these graphs, we can kind of eliminate 2 graphs right off the bat. These numbers right here, they go up in right, each day there's more people, and so our graph would not go down. And so we can eliminate this one, we can eliminate this one. Now it's between these two. Okay. Now if we look at the difference between the two, grab your calculator real quick. The difference between day 1 and day 2, so 125 minus 61, there were 64 people added. Okay, and then 177 minus 125 is 52 people. Okay, so not quite as many people showed up between day 2 as day 3. And then 242 minus 177 would get us 65. Okay, and so we ask ourselves, between the two, what one would it be? And here you see how like we increased, and then we didn't increase quite as much, and then we increased a lot again, right? And so this one, it kind of levels out a little bit too much to represent the data. Okay, this would be like big growth on day 1, from day 1 to day 2, a little bit on day 2 to day 3, and even less on day 3 to day 4. Okay, so this one does not represent the data, and our choice is A. All right, when Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes, and then he slows down, stops, and stretches. After this, he increases his speed to a speed that's slightly lower than what he was before, and he jogs a little bit for a short bit of time before slowing down to stop again. And we need to sketch a graph that would show Malcolm's jogging speed during his workout. And we're supposed to label each section. Okay, so first off, we'll probably make this time. Time is usually a good thing to put on the x-axis, and we'll call this his speed. Now it doesn't tell us like any units, so we'll go miles per hour for speed. Now time, it does give us a unit. It says for several minutes, right? And so we'll make the label in minutes. Okay. Now we don't need any like numbers here because it doesn't give us any numbers. It's just looking for a general sketch. So we know that this is pretty much at 0 when he starts. He gradually increases his speed. Okay, so he gradually goes up in speed. And then he jogs at this level for several minutes. Okay, so he gets up to his speed, and then he just jogs at that speed for several minutes. Okay, then he slows to a stop. So that would look like he's slowing down, slows to a stop. Okay, he stretches for a little while. For a short while. Let's see here. He stops and stretches. Okay. So if we want to, we can maybe go a little bit while he stretches. And then he gets back on, and he increases to a speed that is slightly lower than before. And he jogs for a short while before slowing down. Okay, so he increases again, but not quite as fast as he was before, and just for a short while, and then he slows back down to a stop. So that's how we could label, or that's how we could draw our graph based off of this. All right, that's section 1 of chapter 4. Your homework assignment is fairly short. If you have any questions, let me know.